Welcome to my channel, everybody. Suppose we want to get the mean of a given set of numbers and we don't want to use a calculator. How do we do that? I'm going to suggest a method called the assumed mean or guessed mean. What we do is we guess that our mean could be anything in between there. If you check, this set of numbers is in ascending order, starting from lowest to greatest. So you choose a number in between that is bigger than the smallest but smaller than the biggest. I'm going to choose 13. I'm going to just pick 13 as my assumed mean. Then I'm going to work from there. What I'm going to do now is I am going to record deviations in these columns. If a number is smaller than this assumed mean, I'm going to record the deviation on my left. If it is bigger, I'm going to record the deviation on my right. For instance, 8 subtract 13 is -5. So I'm going to write 5 on the left. 9 subtract 13 is -4. So I'll write 4 this side. 10 minus 13 is -3. So we write 3. 10 again 3. 12 minus 13 is -1. So I write 1 this side. Now I come to the other numbers. 13 subtract 13 is 0. So I don't have to record it on any side. So I leave this deviation. It's a 0. It falls neither to the right nor to the left. So here I'm going to have positives here to the left, negative. 13 also, omit that. 14 subtract 13 is a +1. So I write a 1 on the positive side. 15 minus 13 is 2, and it's a positive. 16 minus 13 is a +3, so I write it there. Then I sum these deviations. 5 plus 4 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 16. But these are negative deviations, so I'm going to have a total negative deviation of -16. Let's do the same on that side. 1 plus 2 is 3, 3 plus 3 is 6, and this is a positive. So I'm now going to have 6 subtract 16, and that gives me a -10. Right, this total deviation of 10 is what I'm going to use to adjust my assumed mean so that it is the exact mean. What I'm going to do now is I'm going to divide this total deviation by the number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to divide by 10 there. And that gives me -1. So what you do is, this 13 here, you are going to subtract 1 from it to get the true mean. What this indicates is that, no, the 13 that you chose is too big. Subtract 1 from it, and that is the exact mean. So my mean becomes 12. That is my exact mean. It's 12 coming from that. Suppose you had got this one bigger than this and the total deviation was a positive. Let's say you got a +1. What you're going to simply do is you're going to add 1 to this 13 after division, of course. So you are going to get what is called the average deviation. Divide the total deviation by the total number of observations. Okay, suppose coincidentally what you picked is the actual mean. Let me pick 12 this time. So I am going to use 12 as my assumed mean. I'm going to assume that the mean is 12. Again, let me repeat, you pick something that is bigger than the smallest but smaller than the biggest. So let's go through that. 8 minus 12 is -4. So I write 4 this side. 9, that's -3. 10, -2. 10, -2. 12 is neither positive deviation nor negative deviation. I leave it out. 13 minus 12 is 1. Which side? This side. 13, 1. 14, 2. 15, 3. 16, 4. Let's see what this sums to. 4 plus 3 is 7, plus 2, 9, plus 2 is 11. So the total deviation this side is -11. If I do the same to that side, 1 plus 1 is 2, 4, 7, 11. Okay, so my total deviation now, I'm going to call it total deviation, is -1. That is now, sorry, no, not -1, it's 0. Because if I say 11 minus 11, I get 0. So then I divide this by the total number of observations, which is 10. And this gives me a 0 still. So what it means is, what you chose here, 12, you don't have to add anything. If you want, you can add 0. But that is your actual mean. That means what you assumed to be your mean is the actual mean. This is how the method of assumed mean works. I can survive without a calculator by using that method. Thank you so much.